Okay, let's have a look at this example. It says, show that the equation x cubed plus x minus 3 equals 0 has a root near 1.2 and find an approximation to this root correct to 3 decimal places. So we're going to find a closer approximation for the root. What does this mean? This is not written in our normal function notation format. It says show that that equation is equal to 0. Well, what this actually means is if I graphed that cubic, where would that graph equal 0? Or where would y be 0? We know that that translates to, this is y is equal to 0, the x-axis is y is equal to 0. So if I want to know where this function, which is x cubed plus x minus 3, is equal to 0, where do these two coincide? So this and this function, x cubed plus x minus 3. Now, actually, I'm going to take that axis out because I don't know this graph well enough. What I do know about this graph is it's a positive cubic, so it's going to do that. And again, to be honest, I don't know where that x-axis is, but they're saying that, and so I don't know if it's this root, or this root. But one of these is near to, and I'll just say this one, 1.2. So it's approximately near to 1.2. Okay, so how would I show that? Well, if that is an approximate root, it should make that equation true. Should make the equation true. So if x equals 1.2 is an approximate root, it should make the equation true. It should satisfy the equation. That is, that x cubed plus x minus 3 equals 0. So we're going to show that. Therefore, the left-hand side is x cubed plus x minus 3. And we're going to put in 1.2 cubed plus 1.2 minus 3. So you can see there from the calculation that it's not quite 0. It's equal to, what was it, negative 0.073. Let me just check that. 72. Doesn't really matter. Okay, so we're getting close, which is approximately equal to 0, which is what I wanted my right-hand side to be. So 1.2, not quite good enough. Now, let me find my second approximation. And how do I do that? It says that x2 is equal to x1 minus the function value at x1 on the derivative of x1. I've got a few things to work out before I can sub into that equation. Okay, so going from the equation, you can see that we know that x1 is our 1.2. We've worked out the function value at 1.2. That was done here. So we're going to use that. We need to work out the derivative. So the derivative is 3x squared plus 1. And we need to work out the value of the derivative, the gradient, at that 1.2. So we sub in 1.2 and go to your calculator and you'll get 5.32. So now it's these, we need this value, we need this value, and we need this value. And we sub those in here. So we're at 1.2 minus, and our first function value was a negative, over our 5.32, and we get this 1.21. So we're getting more specific. It's not just at 1.2, it's at 1.2135. This would be a better and closer x value for the root. Let's test that because the instruction was actually to find an approximation to this root correct to 3 decimal places. This one wasn't correct even to 1 decimal place because that would be a 1. And we want all zeros, don't we? Because that's ultimately what we're trying to get. So we want 3 zeros after the decimal point. So we're going to put this value in to our calculation now. Now, just a little hint about your calculator. What I previously had was this answer. So this was on my calculator. I didn't delete it. I want to use that number and cube it and add it and subtract 3 because that's the function. So you can see I've done that, and I've just used the answer button to do that. So don't delete these numbers on your calculator. And when we do that, we're getting 0.00066, which I suppose when rounded is 001. So we need to go through that process one more time. And you can see I've done that there. I've found x3 now. So x3 was our x2, this value, the 1.2135, blah, blah, blah. Using the formula, subtract the function value at x2, which is this value here. So it's the 0.006. This one I had to work out separately. And you can see I've done that there in green. The gradient at my new spot, 1.213, and that gives you 514, 41799, blah. When you do this calculation to get your x3, this is my new x3 value, and I now test at x3. So this is what I believe now is closer, certainly closer than 1.2. My second was what, 1.2135. Now I'm saying 1.213410877. And when you put that in your calculator, and again, because I had needed to do this calculation on my calculator, you can see that I'd just recall that, didn't delete it, called it answer, so I could nicely do the answer cubed and the answer and subtract 3, and now I'm getting 1, 2, 3, 4, 5 zeros. So that's very, very close to 0. That's as close as they wanted. And so we've shown that this answer would be a closer approximation, and we could also round that to 3 decimal places, 1.213. Should be right now to do some questions from that exercise. Just before I finish off, you can see that Newton's method does rely on your first approximation being close. Now, if that's not the case, then it doesn't actually work. Newton's method won't work. So this next example actually shows that, but I'll go through that in a separate video. So you could get started, do any questions from the exercise that are indicating that this is, they're giving you a value that is close to the root, and you can go through getting those components of the formula and finding your closer approximation. And you could view this one when you come across it. You could view the next video when you come across a question that might indicate that the value given isn't close enough to the actual real root.